So hello, welcome to week 2 of this course. Um, Last week we went over, basic sketches, extrudes, and revolves. But now we're gonna go a little bit more in depth with making your sketches to kind of give you the tools necessary to create the geometries you're looking for in a nice and efficient way, right? So to do that, last week we did a lot of dimensional tolerancing by using the sketch dimension tool to set like lengths and distances relative to each other. But today we're going to be messing with geometric constraints. So using geometry to, create your specified geometry. And then we're going to be teaching you a couple other tools to make more organic looking shapes. So yeah, we talked about constraints like very briefly last week, but we're going to go a lot deeper today. So essentially, it's a tool to help you define your sketch in a better way, right? Again, we've been using like the dimension tool to relate different elements of a sketch to each other, but there's many ways or many other ways of doing that, right? So if you've all taken geometry before, a lot of these will probably sound familiar to you, especially like parallel and perpendicular. But there's a lot of different geometric constraints that you can use to constrain your model, right? You'll be using coincident a lot, at least I do. So that's the one on the very top. And it's basically just moving one point to another, right? I'm just going to do a quick demo on a lot of these, but you can kind of look through these on the slides. Again, I'm pretty sure they're available to you on the Discord, but I'm just going to run through them in Fusion just real quick. I should probably boot up Fusion to do that. But yeah, a lot of these are going to be ones that you use very often. I find myself using like coincident a lot along with concentric. Midpoint's also pretty nice if you want like something to be in the middle of something else. But again, a lot of these names are kind of like self-explanatory, so I won't go too deep into what everything means. Another notable one is the fixed/unfixed one. I generally recommend you try to avoid this constraint, just because like it's not using any geometry. It's just like I want this point to stay here, but I don't have like a geometric or dimensional reason why, right? Most of the time, instead of using a fixed or a fixed constraint, you can use a combination of these plus a dimensional constraint to fully constrain your part. So the fixed constraint is an option, but like I highly recommend you try to avoid that. But yeah, I'll be teaching you all of these in just a little bit. There's a couple other ones here that are also pretty useful. Equal is definitely something you're probably going to be using a lot, just because if you want two things to be equal to each other, you can use this instead of using like a dimensional constraint. And that's useful down the line for like, let's say you have a really big complicated part and like you have 5 sides that are the same length. If you set them all to be equal, you can change one number and then all of them will change, right? Instead of having to change all 5 of them individually. Does that make sense? So it's kind of like about efficiency, but it'll also clean up your sketch. And you'll kind of notice when you start doing them that there's multiple ways to approach it. I'm going to assume Fusion's booted up now. Okay, cool. So, update later. Of course, to create any of these constraints, you're going to be in a sketch. So I'm just going to create some generic sketch first. I'm going to choose this random plane. And we've mainly been working over here, right? We've been drawing shapes. We've been maybe using the trim tool to cut away. I'm going to hide this. But if you see all of these red icons, those are all the things that were on the slides beforehand. You can also click on the constraints drop down and you'll see there might be a couple others that may not be up there. But yeah, I'm just gonna run through a couple of them. So again, like coincident is pretty useful. Let's say I just like have this circle here, and I want this, like, let's just say I have this random floating line in space, and I want to make this line like coincident with this circle, right? I want it to touch this circle. So I could like drag it from like drag the endpoint to here. But in most cases you can just select both of them by like holding shift. So I shift click this and I shift click that, and then I find the constraint that I want. Another thing to note is that it'll kind of gray out a lot of the things that like don't work with the certain parameters that you select. So like I selected a circle and a point, and it won't let them be like vertical to each other because that just like doesn't make sense. But you can see like I can choose coincident. So if I click on it, you'll see the line, the end of the line connects to the circle. Another thing is like if you want something tangent to something, I find that to be very useful. So right next to the coincident function is the tangent function. So I can like take this circle and make it tangent to this line by just clicking both of them. And then you can see this line is nicely tangent to it. And if I like manipulate it, it's going to stay tangent, right? Again, there's a bunch of them, but I'm just going to let you guys run loose and try all of these with the next assignment. So if you want to go into the Discord, you can download assignment 4. And I'll do a couple of these on screen, and then I'll let you guys go, and then you can try all of these functions on your own. It's in hashtag resources if you were wondering where it was. So just download the file and upload it to your Fusion. So over here, if you open your data panel, there's this big upload button. Oh, I should probably change this. There's a nice upload button that you can use to upload certain files. So for me, I'm going to find it on my computer. And then it'll ask you if you want to upload it, which I do. And then it'll upload in whatever folder you chose. Okay. Raise your hand if you can't access this document. All right, cool. So I'm going to click on this front plane here. You can kind of see, if you zoom in, there's like a couple like different words or directions for you to follow and kind of use these constraint tools to make them a certain way. But of course, you need to be able to edit all of these first. So like last week, I'm going to go back and edit a sketch that's already been made. So if we go in our timeline, there's this sketch right here. I'm going to right click it, and then I'm going to click edit sketch. So now I'm in the sketch. If I like try to manipulate things, you can see all of these are like movable lines and circles. But now we can start applying the different geometric constraints. And again, most of the time you're going to be using these geometric constraints to fully define your geometry. But because all of these are just kind of floating in space, most of them are probably going to stay blue. So don't be too scared if it's blue. But again, for the most part, when you're going to be using these in a real sketch, you're going to want your full sketch to be black and fully defined in the end. And this will tie into your homework tonight or this week. So I'm just going to start doing a couple, and then I'm going to go around the room to see if anyone needs help with this. So I'm going to start out with this first one over here. It says to make these two lines perpendicular. So I'm going to hide the data panel so I can see a little more of these. I can see there's the perpendicular tool over here. So what I'm going to do is I'm going to hold shift and I'm going to select these two lines. And then you can see I'm just going to press perpendicular. And then we have a nice 90-degree angle. Again, it's nice and clean. Using geometric constraints, you could use like a dimensional constraint, but the point of these geometric constraints is that you don't do that, so you can make it nice and clean and readable. So I'm just going to do it the wrong way to show you. So sketch dimension, I could click these two and I could set the angle to 90. And sure, this will give me the same effect that I'm looking for. But like generally, if I want this thing to be perpendicular, I'm just going to make it perpendicular instead of setting it to 90. Unless this angle is like subject to change, then I would use this. So yeah, these geometric constraints are really useful. When I first started CADing, I didn't know about them, and I just used like sketch dimension for everything, even for things that were like coincident. So I'd set like distances to 0, and then it would like freak out and break the CAD. So please don't do that and use coincident or all these geometric constraints. Moving on over here, it says make 3 lines parallel to each other. So there's this parallel tool over here. I'm going to click on these two. They're going to become parallel. And then I'm going to click these two. They're also going to become parallel. You can see that like sometimes they'll like overlap with each other. So if you have your tool like on, you'll see the icon is like highlighted blue, and it won't let me like drag these things. So to get out of the tool, you just press escape. So the tool goes away, and then you can kind of manipulate your lines and circles and arcs and whatnot. So most of the time, when you create a geometric constraint, the computer is just going to automatically move one to like solve the math problem. Because you basically give the computer a math problem whenever you assign it a constraint. So sometimes you might want to think about the order you constrain things to make sure the lines go in the way you want it to. But generally, I'm pretty sure, yeah, I'm pretty sure it like jumps from the first thing you select to the second one, but I don't remember. Again, this is why you want to make sure like you fully define your sketches, because if one of the things aren't defined in space, they're probably just gonna collide in a random spot in the middle. Like sometimes it like averages out the middle and then like moves them to that center. Sometimes it'll move one point to another. It can be kind of unpredictable if you don't use multiple constraints. Yeah, but it's the reason why it's harder to control is because all of these are undefined in space. So if you use something that is defined in space, so remember how I was talking about like the blue and black lines last week? If you were if you apply a constraint from something that's blue onto something that's black, that blue thing is going to always fly to the black thing because the black thing cannot move. But if both of them are blue, they're both going to kind of fly into each other, which is why it's important to start building your sketches to be defined as you go. Yeah, so to control that, I always start by creating a sketch at the origin, right? Because the origin, when you first make a sketch, is the only defined spot in your whole sketch plane. So yeah, so like let's say, okay, I'll just do a quick example real quick. So I'm gonna make a sketch right now. You can see this point is the origin, right? If I draw a circle from the origin, it's gonna be blue, but it's because I haven't specified the diameter of the circle yet, right? So because it's on the origin, I can set the size. Oh, it's not on the origin, But because it's on the origin, you see it's black. Yeah, so I've centered it on the origin, so that's defining it in like an XY space, right? And then the diameter fully defines it, right? That means the circle can't get bigger and it can't move anywhere. Yeah. So, mhm. Yeah, that's basically the same. But like concentric is just making sure the arcs of the circle are centered around the same center point. Mhm. Yeah. Mhm. So it's like useful for like let's say you have like a bolt hole and you want like the cap of the bolt to go into your part. You can make a concentric circle that's a little bit larger than the bolt diameter or the head diameter, and then that way it'll be a nice recessed hole that's centered.
So like you will like make an assumption and you'll like
especially with the horizontal and vertical thing, it'll choose the closest one. Yeah, so like the closest one is like vertical, so then it's like so you kind of have to like encourage it in certain directions. I don't know. In other programs that I use, they have like horizontal and separate buttons. Yeah, but then I don't know. Maybe they wanted to reduce the number of icons and they did that. It would have been, at least in my opinion, a lot more straightforward if we just did separate ones. Okay. Is anyone confused about the different or any of these like different scenarios? Because if you are, I can like do it for you right now. No? Did you guys all finish them? Okay, what's up? Okay, so make the circles concentric. So when you do that, when you want to make them concentric, you want all of the center points of the circle to be on top of each other. Right? Does that make sense? So over here, there's the concentric feature right here. And then I can just start clicking these circles. So if I want these two to be concentric, bam, like that. And then I'm going to click these two, and then they're all concentric. So collinear basically means on the same line. So like linear is like line, and then co is like the same. So if you want something to be collinear, which one is it? Okay, yeah, this one. So collinear is right here under concentric. If I click on these two lines, they'll kind of like merge themselves onto the same line. But yeah, if you're ever confused on these definitions, you can go back into the slides. The descriptions are right here. Or if you're on Fusion, you can just kind of hover over the constraint if you're confused about what it means. Okay, yeah. So for the last one, you want to line up the centers on the same horizontal plane. So I want these lines or these circles to all be like horizontal to each other, right? So these two are basically horizontal to each other. I'm just going to move it away a little bit just so you can see the difference. But I'm going to use the horizontal vertical tool, and I'm going to select the centers of the circles. And it should start making them horizontal. You might notice that if I try to do it over here, it'll make it vertical. And that's just because Fusion combines the horizontal and the vertical tool. So it'll basically choose whichever one is closest, like horizontal or vertical, and then it'll pick that one for you. So in this case, sometimes you need to encourage it to be like correct. So I'm gonna undo it real quick. And then if I move this circle a little bit closer to horizontal, if I use the tool again, it should make them horizontal. Yeah. Is there any other example you want me to run through? If not, I'll just move on to the next assignment. All right. Again, if you have any questions about this, feel free to ask me later. I'm happy to go over it with you. But we're just going to move on to the next assignment here. Okay, so for this assignment, we're going to be creating this basic gear over here. And this is why, or this is one of the assignments where the timeline is very important, right? So I've been emphasizing on like screenshotting your timelines, and this is one of the main assignments that it really matters on. And the reason for that is we're going to be using specific tools that I want you to utilize, just so I know that you know how to use it and you'll be able to use it later. And I'll explain why in a little bit. So looking at this gear, you can see this sketch over here. We're going to recreate it today. And you can kind of see the process at which this happens, right? We're gonna build, or we're gonna sketch this circle. We're gonna make this tooth, and we're gonna copy the tooth a bunch of times, right? Again, we're gonna try to do this in a very efficient way. So if we ever want to go back to change things, it'll make it really easy for us. Because normally on a gear, all the teeth are the same, and you don't want to have to CAD like 500 teeth when you can just CAD one and then copy it a bunch of times. So we're going to do that today. Oh, that's convenient. Okay, so I'm going to create a sketch. I'll just restart. Why not? So I'm going to create a sketch again. I'm choosing the top plane up here, but again, you can choose whatever plane you like. We're going to first start by creating a circle. And there's kind of a different approaches that different people take, right? Some people like to just throw out all the lines and geometry, and then they like to add dimensions, or other people like to dimension as they go, right? There's no right or wrong way. It's just kind of a matter of preference. For me, sometimes I like to add dimensions as I go, and sometimes I like to do it the other way. It just kind of depends on the part. So I'm just gonna do it a little bit. I'm gonna do a little bit of both for this. So I'm just gonna start by dimensioning this circle so it's nice and defined. Again, you see this circle is black, which is what we want. And then I'm gonna sketch this tooth profile. Now, just kind of like we did the revolve last week, I don't have to sketch the full tooth profile to get the geometry I want. In this case, I'm going to sketch half the tooth, and then I'm going to copy that half to create the full profile. So to do that, I'm going to start by creating a construction line. So construction lines are really useful for when you're creating things, especially when you pair it with different constraints. It'll allow you to kind of hone down your geometry without adding complexity to like your extrusion. You'll kind of see what I mean in a little bit, but basically when you go to like extrude or revolve things, it will ignore the construction lines. Fusion is going to ignore those, but they're really useful for you when you make things. I guess one example is like when you make a center rectangle, it actually creates two construction lines for you. So I'm just going to do it real quick. But you see those dashed lines, right? Those two are construction lines, and paired with geometric constraints, it constrains this rectangle to the center, if that makes sense, right? So that's how Fusion uses it, but we can use it when we create our own design. So in this case, I want to create a construction line like vertically here, and I'm going to use that construction line to mirror the gear profile later. So to create one, you have like this sketch palette over here. You can see the option to make the line construction or not is here. I'm pretty sure you can press like C as well. Oh wait, no, that's circle. I forget what the hotkey is. But you can also change things to construction later. So if I wanted to make the circle construction, I can click on it and then change the line type to construction, and you'll see it becomes a dashed line. And then if I want to change it back, I'm going to click it over here again. But I'm going to start by making this vertical line constructed. You can see it's nice and dashed. And when you start to create other lines, it might be construction as well. So I'm just going to turn that off because I want the tooth profile to be not construction. So I turned it off. I'm going to create some lines here. And then I can start adding my constraints, right? So in this case, I'm going to add dimensional constraint. Maybe make this like 70. Make this like 7. And then with the sketch dimension tool. And then I'm going to specify this angle right here. I'm going to say 100 is nice, right? So I have this like half tooth profile right here, and then I'm going to copy it. Is everyone good here? Yeah? All right, cool. So I'm going to go under create, and I'm going to create a mirror. Over here, it'll ask me to select objects. So I'm going to select these two lines because I want to copy those two. And then it'll select the mirror line, or it'll ask me for the mirror line. So I'm going to click over here to specify the mirror line. And then I'm going to use the construction line that I created earlier to mirror the geometry. So if I press OK, it'll copy the geometry, and we're happy. And again, as proof that this is really nice, we can modify these parameters on the original side of the sketch we made, and you can see, like, if I change this to 5, both of them change, right? These lines over here are defined by these limited, or these like dimensional constraints that I have over here. So it's super nice for when you want to go back to edit things. I can just change one number or a couple numbers and everything will change along with it. So we have a single tooth gear, but obviously to make a full gear we want more than one. So now that we've mirrored it, we can create more. So over here under the mirror tool, there's the circular pattern tool, and it'll allow us to create copies of this tooth about a circle, right? So for objects, I'm going to select these lines, and then the center point is going to be the center of the circle, which also happens to be the origin. And then I can specify the quantity. So how many teeth do I want? So if I wanted like 10 teeth, I can type in 10. If I wanted more, maybe I want like 14. It'll generate more, and it'll all be revolving around the center point of the circle. So I'm satisfied with that. I'm going to press OK, and you can see I have all these teeth here. Everyone good? No? Like this one? Okay, so to fully constrain this one, you want to make sure that the end of the line is coincident with the circle, right? So the end of the line ends at the circle. You want to make sure it ends at this line, and then you want to specify the height of this line, and then also the width of that line, and then the angle in relation to these two. So if you think about it, like, this is kind of like the 5 millimeters here is like the X, and then the 70 over here is the Y, and that fully defines this point right here. And then if I add an angle here, it'll define the direction of this line in relation to this. And if it ends here at the bottom, then it's fully constrained. Does that make sense? Yeah, so like you can see how like the line ends here. So because it can't get any longer on this side and it can't go past this because it's also coincident with this line, once you set the angle, then the length of this line is going to be fixed, right? Like if I deleted this constraint, it'll turn blue because like I can move along here and the angle will change along with the length of the line. But once I add back the dimension, then it'll be fully constrained. Yeah. Sometimes like your sketch can be deceiving, so sometimes something will be a little bit blue and it looks like it should be defined. Usually, like what I like to do is if I see something blue, I'll just try to drag it in a certain direction. And if it goes in that way, that means it'll show me that it's not defined. So like sometimes like this line might be like super duper close to the end of the circle, but it's actually not coincident and it'll show up as blue. Um, but if I mess around with it, then I usually find it. Yeah, okay. Sometimes you'll have to constrain something else for it to constrain uh, another thing that is in relation to it. But anyways, we have this profile. I'm happy with it. I'm gonna finish it and extrude it just like I've done on past parts. Um, you can, but I'm gonna explain why you don't want to do that in a little bit. Um, so when it comes to profiles, because all of these teeth are like a single closed body, you have to specify and select all of them. So I'm just gonna go around this wheel, select all these teeth. I probably could. I'm just like clicking all of them. Um, for distance, I'm just going to specify some arbitrary distance for now. And we have our gear, right? Everyone good here? Yeah. Okay. So we have our gear, but there's no way to mount it on something, right? We don't have a hole in the center, and we can't really put it onto anything. And if you see over here, this hole actually has threads. So someone asked, like, why didn't I just create a hole in the gear from the get-go? And it's because I'm going to be using the hole tool to create the hole along with the threads. And the reason why this is important is it retains more data than just creating like a hole from like an extrusion or a revolve, right? So when we CAD, we're not just CADing for ourselves, but for other people who might interact with this part. And oftentimes we'll CAD something and then we'll send it to someone to get it machined, right? We like send it to someone to make our part, and when they create our part, they want to have as much data as possible when it comes to all the features of our design, right? So if we want a threaded hole, or if we just want a simple hole, we could technically create just like a sketch, draw a circle, and then extrude it out. But we lose some of the data because with the hole tool on Fusion, it'll tell you like the exact diameter of the hole and like how deep to go into the hole. And it's also very nice for when you use CAM, which is I think it stands for computer aided manufacturing. Um, but essentially, you're gonna program a computer to create your part for you. And to generate those toolpaths, it'll use the data from Fusion 360 to create the toolpath. And it might treat an extruded cut as like a pocket instead of an hole. So depending on like the scenario, the CNC machine might do something that you don't want to do, like using an end mill instead of a drill bit to drill a hole. If you don't know what I'm talking about, it's okay, but it's just kind of like using the wrong tool to like not a drill bit to drill a hole. So when we use the hole tool, we retain that data when we send it off to someone. So that's why I highly encourage you to use this tool. It's also really nice for creating threads. Instead of having to like model the thread profile, it'll just make it for you, which is very nice. So yeah, this hole tool is right next to the revolve, and then it'll allow you to select different points at which you want to drill a hole, right? Something that you could do is you could create a sketch and then put in a bunch of points on that sketch, and then use the hole tool and select all those points on the sketch to create a hole. But in our case, we're just putting it in the center, and we drew everything at the origin, so it should be pretty straightforward. So again, it'll ask me where I want to create a hole. In my case, I just want it to be in center. So that should be centered at the origin right there. And then you can see all of this data right here, right? To us, it might seem simple, but like all of these options could be like very valuable to a machinist who might make your part later on, right? So you can specify different kinds of holes. So like a counterbore would like make one part of the hole a little bit wider than the other. So if you wanted like the bolt head to be flush inside your part, you'd usually use like a counterbore, or like a countersink would be like a counterbore but with an angle. So we have like those kind of like flanged like screws and stuff like that. You can select that. Again, I'm just gonna leave it as simple because we just want it to be a straight through hole. Over here, you can specify like what kind of hole. So it could be like a clearance hole. In our case, we want it to be tapped. So tapped is just basically creating threads like a nut to use for a bolt. And then there's like a taper tapped. So these are all many different options for you to use. And this data is valuable for machinists later on. So in our case, I just want to create a tapped hole. Over here, you can like specify more parameters, like how deep you want this hole to be. You can specify the taper angle of the drill bit, so kind of like how pointy the end of your hole is going to be. For us, it doesn't really matter because we're going all the way through, but if we weren't, you know, that could be an important thing for you depending on what you're doing. And then again, a lot more data for you to go through. So you can select the type of thread depending on the standard that you're using, you know, the size, and then, you know, a lot more data. Like you can change it to left hand if you want to, but normally most things are right hand. Anyways, this is a lot of valuable data for people later on, and it makes our lives easier because we can just kind of click where we want a hole instead of just creating like a whole sketch and circles and extruding it. But yeah, I like that, so I'm just gonna press OK. It'll create this hole, and then you can also see in the timeline how the icon is a little bit different from the rest of them. So over here, you can see that this is the hole tool instead of like an extrude or a revolve, and this is why I was explaining why your timeline is like important to stay clean, right? So as someone who CADs a lot, you can kind of read someone's timeline and go through their process on how they design their part. And as someone designing the part, you can try to make that as easy to read as possible. So this is pretty simple just because we only have 3 different things. So it's just like, oh, I made a sketch, I extruded that sketch, and then I created a hole, right? But when you create more complicated parts, this thing is going to go way across your screen and sometimes even beyond that. So having something nice and clean and being and easy to read is very, very nice in the future for yourself if you want to change things, but also for others if they want to understand what you did. But yeah, that's this assignment. Again, when you screenshot, make sure your timeline is visible. I don't want to deduct points. So yeah, I'm telling you now, please do that. If you don't, I'll be sad because I don't want to take points away from you. But yeah, is anyone confused on this? I know I talked a lot about why it was really important, but I'm just saying that to emphasize the point, if that makes sense. Yeah, everyone's good? Dope. Okay, so that is that assignment. We have one more assignment today, and then we'll be done. This one is a little bit different from the rest of them, but it's pretty cool as an example for a new tool that you guys may not have used yet. So for this assignment, we're going to create a hair dryer, and to do that, we're going to create a loft, right? Oh, yeah, what's up? Yeah. Okay, so the mirror tool can be used in many different ways. You can mirror objects when you're out of a sketch. So let's say like I created like some geometry on the side and I wanted to mirror it. I could mirror it. I can mirror the object, but what I think you're trying to do is for the other part of the tooth, right? Yeah. So you have to make sure you're in your sketch to create the mirror. So you can mirror objects, but you can also mirror your sketch. So you have to make sure you're in your sketch. So down here on your timeline, there's your sketch, and you have to make sure you're editing it. A good way to know that you're editing a sketch is if you see this green check mark. But now if you go and like create your mirror over here, it should pop up like this, and then you select your lines, and then select the mirror line. Yeah. Okay. So to make this hair dryer, we're gonna be creating planes. So before we've been kind of using the 3 planes that are given to us when we start our model, but in certain circumstances, it might be nice to create your own planes to create your geometries, if that makes sense. So in this assignment, we're going to be creating a bunch of planes, and then we're going to be creating separate sketches on those planes to create a loft. So you can kind of see what's going on over here. These orange squares are different planes, and you can see how these circles are kind of stacked on top of each other. And then when we create a loft, it'll create a nice, smooth, solid body constrained by these circles. So I'm going to create a new document up here. And before I create sketches, I'm going to start creating planes. So you can see over on construct, there's a bunch of different plane options. I'm mostly going to be using offset plane, and I'm also going to use mid plane just so you guys know what it is, but you can use all offset planes for this. But yeah, again, I'm going to create an offset plane. You can see, like if I spin around, these planes are all on different axes, and they're all related to the origin. But if I didn't want that, which I do in this case, I'm going to select one of them and I'm going to offset it. So just kind of like how we offsetted like different sketches and extrudes from last week, we can create planes at an offset from each other. So this plane will be created at a distance away from this one. I'm just going to say 40 is okay. And you can see like the grid is kind of like the quote-unquote floor of your model. You can see how this plane rises above it. So that's what we want. I'm going to create two more planes. So I'm going to create a plane. I'm going to offset it from this. Maybe I'll create the offset at, that is not a number, maybe 100. And then to finish it off, I'm going to create a midplane. Again, you don't have to do this. You can just use another offset plane, but I'm just showing you the different options. So a midplane will create another plane in between two planes that already exist. So to do this, it'll ask me to choose two. I'm going to choose the highest one and then maybe like this middle one. And then you'll see it made a nice plane smack dab in the middle. Does that make sense? All right, cool. And again, if I wanted to edit any of these, I can go back and change them in the timeline. So I can edit like the distance of this one to maybe like 120, and I'll make it a little bit taller. But yeah, now we have our planes. So to construct the body of the hairdryer, you can see how we're creating multiple circles. And these circles are not on the same sketch. We're going to create 4 separate sketches on 4 different planes, and then that'll allow us to get the geometry we like. So again, I'm going to create a sketch. I'm going to choose this bottom plane first, just kind of like how we normally do. And these orange squares are just representations of the planes. So if you want to ever hide them, you can see under construction, there's this eyeball. If you click on it, it goes away. So I'm just going to hide them for now, but I'm going to want to be able to see them in a little bit. So I'm going to start by making a circle. I'm going to make sure it's at the origin, just for simplicity's sake, because we're going to create 4 different circles, or yeah, 4 different circles, but we want them all to be kind of on the same line. So our hairdryer looks like straight and it's not like bendy, if that makes sense. I'm going to assign it a diameter, maybe I'll just start with 100. So we have our circle. I'm going to unhide the other planes. You can see how they're not on the same plane. But now I'm going to start creating more sketches. And instead of the base plane that we selected on the first one, I'm going to choose one of the other ones that we just created. So I'm going to create one, and I'm going to make sure I choose the right one, and I'm going to draw another circle. So this is the second one, so I'm going to make it a little bit bigger. I like that. Again, it's fully defined on the origin, just like the one before it. I'm going to create another sketch, this time selecting the plane above it. I'm going to create another circle. Define that. And then I'm going to create one more circle over here. Maybe like 175. Oh, no, 125. Okay. No, I want this to be a little bit bigger. I'm going to edit it, maybe. Yeah, let's do that. So now I have like a set of stacked circles. Is everyone with me? Okay, cool. So now that I have all of them, I'm going to create a loft. So you can kind of see, like, it'll give you a preview on what it does. It'll take the closed bodies that you made, or closed loops that you made on different sketches, and then it'll create a solid body that like really nicely smooths the geometry between the two. So I'm going to create a loft, and then I'm just going to start selecting the profiles. And then you want to make sure you select them in the right order, or else it'll start looking wonky. I believe, yeah. So usually you just like select the bottom one and then just make your way up, but I accidentally selected the second one instead. So you can change the order over here. But yeah, it'll give you a preview. I think that looks fine. You can see now we kind of have this nice hairdryer base looking thing. Yeah. Raise your hand if you're confused about any of this. Oh, okay. Yeah, so I'll do it again for you. So down here, I'm going to create a loft. And then I'm going to... Oh, why did the sketches hide themselves? And then under profiles, I'm going to just select all the edges of the circles from one side to the other. So this one, this one, this one, and that one. And then it'll create the body. Yeah. So now that we've created this body, we're going to want to hollow it out. So air can't really get through a solid chunk of something. So why don't we hollow it out so it's nice and easy for the air to go through. With this, I'm going to use the shell tool over here, and I'm just going to click on the top face. I'm going to specify the thickness of the shell. So what it's going to do is it's going to hollow out everything inside. So you need to specify how thick the outside is going to be, because it's going to cut out everything else. So maybe for me, I want to do like 10 or something. So you see, now we have a nice hollow shell of our hair dryer. Everyone's good? What's up? It's the shell tool. So right next to the fillet tool, there's this shell icon. Yeah, it'll just kind of tell you what to do. But yeah, we have this nice body right here. But now, oh yeah, I forgot about the fillet. I'm gonna fillet it. So right next to the shell, there's a fillet. I'm just gonna add a quick fillet over here, just to make sure this side is nice and round and I don't cut myself on the hair dryer. Notice that I'm just doing the outside and not the inside. So I'm going to be doing something a little bit later that might break your fillet if you also do the inside. But yeah. So now that I like this, I'm going to start creating the handle for the hair dryer. And to do that, I'm going to create another plane. For this, I'm going to be creating a tangent plane, I think. Oh, wait, no. I'm pretty sure. Oh, yeah, it's the offset plane. and create another offset plane. This time I'm going to push it out in one of these directions so I can create a handle. And for demonstration purposes, I'm going to be putting it a little bit inside our hairdryer. You can also go a little bit outside your hairdryer. That works too. But I'm just going to show you this way because I also want to demonstrate something else. So I'm going to create a sketch. I'm going to create a circle. And sometimes what I like to do is I like to draw out my circle or whatever geometry I'm creating a little bit away from where I want it to be in the end, just to make sure that there's no confusion when it comes to constraints. So in this case, I want this to be constrained vertically. So now that it's a little bit offset from the origin, if I create a vertical constraint, it'll constrain it vertically. So now I can't move it side to side. I'm gonna specify this distance right here, maybe 50 seems like a good number, and then I'm gonna specify the diameter. I'll give it maybe like 60 this time, and I think that looks good. So I'm gonna finish it. I'm gonna extrude it, maybe like 250. You can see it's red because the operation is set to cut. I want it to be join, so I'm gonna join it. Yeah. After that, I want to kind of round the end of this hair dryer, but instead of a fillet, I'm going to add a chamfer instead. I want it to be a nice 45-degree angle. So again, under modify and chamfer, it'll open up this tool. I'm going to select this edge. I'm going to specify a length. I think 5 looks all right. Now we have our handle. Raise your hand if you're still getting caught up. Okay, I'll give you guys a couple minutes. What's up? So I'm just extruding it from the sketch plane. I'm actually gonna exaggerate this issue just so you guys can kind of see what you can do. So I'm just extruding it from the plane, and you can see it kind of sticks into the hairdryer body. I'm gonna fix that in a little bit. If you did extrude it, or if you did start the sketch like farther out and it's just kind of hanging out over here, the way to combine it is to create, I believe, a two-sided extrusion. So if I change this to two sides, I can set the second one to object instead. So if I changed it to object and I selected this, it will like smoothly extrude into the circle, and you can see it doesn't like protrude into that, if that makes sense. To be honest, this is probably how I would do it, but I'm gonna do it the other way just to kind of exaggerate a problem so I can show you how to fix it. Okay, so does yours look like this right now? Like okay, I'm gonna go over how to fix that in just a second. Yeah. How did I get the handle here? So what I did is, if you look in the timeline, I created a plane that's offset from one of these planes at the origin. And then I just drew a circle in the sketch right here. I made sure it's nice and centered on the hair dryer, and then I just extruded it. And then in my case, you can see how the handle kind of sticks into it, and I'm about to fix that. Yeah. Is everyone caught up? Okay, cool. So let's say you come into a scenario when you did something like this, you have like this feature that you don't like that's kind of interfering with another feature that you have. This is just one use case, but I'm sure you can find many other use cases for this. But you can actually move certain operations in your timeline. So in this case, like we have our shell right here that we did right after our loft. And we can move this to kind of change the geometry to maybe something that we desire. Again, sometimes this might go the way you want it to do or to go, but sometimes it won't. And the shell isn't the only feature that you can do this with. You can do this with a lot of different features, depending on how you modeled it, and sometimes it's kind of useful. So in this case, let's say I wanted to eliminate this kind of ugly gap right here, and also hollow out the inside of the handle so I can like put electronics or something inside of it, right? So I could just like make like an extruded cut or shell this separately, but what I could also do is I can move this shell forward in the timeline, and it'll create the shell based on everything before it, right? So if I hold down on the shell, and you can see with this like little line, it's showing where I can place it. I'm going to drag it all the way over here, and when I let go, it will change. So you can see how it shelled out the the head of the hair dryer, but then it also shelled out the handle, and it made the handle hollow. So that's a good tool for you, or just like good thing for you to know, that sometimes you can change the order at which you do certain operations, and it could change your geometry. Yeah, like right here. Okay, so to do this, I created, using like the construct tool, I created an offset plane, and then I offset it from one of these planes. In this case, I chose this one because I wanted it to extend like this way. I created an offset plane from there, and then I created a circle on that sketch, and then I extruded it, and a chamfer, and then I moved the shell. So did you move the plane like outside of the body of the? I'm just gonna quickly go over the homework to remove any confusion. So the homework today is to create this extrusion profile. Um, so I want you to submit your sketch, right? So don't exit the sketch. Submit me the open sketch so I can see all the dimensions you inputted. But the point of this assignment is to utilize geometric constraints to its fullest extent. So all you should need are these numbers on the screen. So this is kind of like a hint to you to create your sketch. I did like one part of the profile and then I mirrored it along this plane here. And then I did a circular pattern and I copied it 4 times. This is in the slides. So if you're confused, this is basically like a hint. So I created like a square construction lines. So it's a nice square, and then I created all my geometry off of that. But yeah, all the required dimensions are here. You shouldn't need to add these numbers more than once to make it fully defined. So your sketch should look something like this. If you're needing to input like this radius more than one time, that means that you did something wrong, or you can insert a geometric constraint in place of that dimensional constraint. So I would like all of you to only have these numbers once, if that makes sense. But yeah, this is probably like the hardest homework assignments I'm going to give you this whole semester. So if you have problems with it, just reach out and we'll help you through it. Because the point of this is for you to understand why geometric constraints are important. But anyways, I'm going to go back and finish this wire real quick. It should be pretty quick. I'm just going to create a sweep off of this handle. Let's see, 7 minutes. Okay. So I'm going to create a sketch. To create a sweep, I'm going to need to have 2 separate sketches. So I'm first going to start by making a little circle centered on this. I think I can use a geometric constraint here. So let's say I made this circle. I want it to be concentric. So I'm going to use this old geometry that we've created, and I'm going to make it concentric with this circle. You can see it flies in the middle. I'm going to specify its diameter, maybe like 15. So that's part of the wire, but the other part is kind of the path at which this wire is going to take. So to do that, I'm going to create another sketch, and this time I'm going to select this sketch right here. And you can see that this sketch cuts this whole model in half, which means that it's going to be centered on where this circle starts as well. So I'm going to create a sketch here. It's going to move the hairdryer horizontally, and then I'm just going to sketch the kind of profile that I want the wire to follow. I'm going to create a straight line, and then I'm going to use just this spline tool, the fit point spline, and I'm just going to start clicking away. It's going to make a nice, fun, organic shape. And when I'm done, I'm going to press the check mark. I want the wire to kind of flow smoothly, so I also want this wire, or this spline, to be tangent to this. So I'm going to be adding constraint there. You can see it's a nice smooth transition. I'm going to press OK. Again, this wire profile doesn't have to look exactly like mine. I'm just kind of drawing a random one. And then I'm going to create a sweep. So right above the loft is the sweep. It's going to ask me to select the profile and the path. So the profile is like what I'm going to be kind of extruding along the path. So in this case, it's the circle we created earlier. And then the path is this long squiggly line we made. So I'm going to select path. I'm going to click on it. And then you can see a nice squiggly line. But yeah, that is the hairdryer assignment. Again, make sure you have your timeline included so I know what you did. But yeah, again, this homework assignment, please keep your sketch open so I can see all these dimensions, because that's the important part of this assignment. This is like the only assignment that I really care about the numbers that you use, so please use these numbers that I provided for you. But yeah, also this sketch was made in another program, so you can screenshot it and submit it, but it won't give you any points, so don't do that. You can kind of see this program kind of shows these little green squares of kind of the relations. It's a little bit, it can get a little bit difficult to decipher over here just because there's so many constraints. But that might give you a small hint at what's going on here. But like, for example, like this line here is parallel with this one, along with this one over here. And then this line, that line, and these two vertical lines on the construction square I made are also parallel. I used the equal constraint for the square, so I did one dimension for one of the sides, and then I set like this side and this side to be equal to each other, so that makes it a square with just one constraint, or one dimensional constraint. All these small radii over here are all the same, so this is, the radius is 0.1 or the diameter is 0.2. But yeah, use the trim tool. The trim tool is very useful for this assignment. But yeah, again, if you have any questions, we're happy to help you. Yeah, what's up? Yeah. Yeah, if you guys are good to go, if you got what I said, then you're free to leave. I'm just gonna walk through the sweep again because I know I did that a little bit quickly. But yeah, I'll see you next week. Make sure you fill out your attendance before you leave too, because I don't want to get mad at you for not being here if you were here. Okay, so for the sweep, a sweep requires 2 sketches. So the first sketch is centered. Hello? Why is it not showing? Oh, it's because I hit it. Okay. So this first sketch right here is centered on the end of the handle. Okay. Did you get the second sketch too? Oh, okay, cool. So to create the sweep, you go under create and sweep, and then it'll open this drop down over here. It'll ask you to select the profile and the plane. So you want to, for profile, it'll be highlighted blue. You click on the circle, which is like the profile we're extruding. And then for path, you click on the select to make sure it changes. So you see like the blue changes here. You click on path and then you select the squiggly line that we created earlier. And then you should be good. Okay, cool.